A pie chart. A pie chart is often used to plot relative frequencies when the data are categorical. A cycle is constructed and then is sliced up into distinct sectors, one for each different data value. Each slice of the cycle represents a fraction or a proportional part of the whole. All slices of the pie add up to make the whole equaling 100% and 360 degrees. We have a data set for number of deaths on a given city roads in a year for individuals in various classifications. We have number of pedestrians who died, number of bicyclists who died, number of motorcyclists, and number of automobile drivers who died during that year. And the data set is given in the following table. The table shows that the number of cyclists who died were 280 individuals. A number of motorcyclists were 650. Number of automobile drivers who died were 1,327. A number of pedestrians 1,699 individuals, to make a total of 3,956 individuals. So having these frequencies of deaths classified in these 4 categories, we want to present today this data in a pie chart, and we are using R software to do that. So let's see how we can do it. Okay, now let's create our pie chart using R. What do we need first? We need to define a vector of relative frequencies, and we can create it departing from the data that we have. We have number of deaths for each class. Let me call it deaths. This vector contains these numbers. It contains 1,699 pedestrians who died, and 280 bicyclists who died, and 650 motorcyclists who died, and 1,327 automobile drivers who died. So we need to calculate the relative frequencies. Let me call it F. And for those who watched my previous videos, they know how to calculate relative frequencies. We take 100 and multiply by our absolute frequencies, then multiplied by deaths. Yes, and we divide by the sum of deaths, the total number of individuals who died during that year. Yeah, so we have deaths and we have relative frequencies. And what else do we need to create this pie chart? We also need a vector of those classes. Which classes do we have? We have pedestrians, and we have cyclist, and we have motorcyclist, and we have automobile drivers. Yeah. Yes, so with these two vectors, the relative frequencies and these classes, we can be able to create our pie chart, and we can use a function, a built-in function called pie, and this function require that we enter a vector x vector of frequencies, those numbers, then in this case x equal to f, it needs labels, and the labels you may either use classes or the frequencies depending what kind of pie chart you want to create. Let's for example use classes. In this case, what kind of pie chart are we going to get? We get a pie chart of this kind. Let me zoom it so that you can see it clearly. Yeah, it's here, it's hidden somewhere here. Yeah. So if you can see, this is a pie chart, but we can also customize. We can customize the colors. How can we customize colors for this pie chart? We can, for instance, use different values of colors, of course. For example, rainbow. How many colors? The color depends on how many classes we have. In this case, let's see, will be the length of our classes or our vector f, whatever. Yeah, so the pie chart change into this one. Let me zoom it. Yeah, here we go. Yes, but if you can see this pie chart like this, only the thing that you can read from this pie chart is that the pedestrians pollution is the biggest number, and followed by automobile drivers and motorcyclists, and then cyclists. Bicyclists are fewer. But again, we can't know how many, which percentage has each class has. So we can format this pie chart, and we can show the percentage, the relative frequencies for each class, and then put the classes into a regent. How can we do this? Yeah, we can only change these labels. Instead of using classes, we can use these frequencies, what they change. See, then you get a frequency table like that. But this is decimals are too many. We can also reduce the number of decimals. How do we reduce the number of decimals? We can round our class vector. Let's round it, round, so that we can only have a single value after the point. Yeah, the single decimal. Let's give it one decimal number. We change f into this one, and then the pie chart will change into this one. You see, now at least the numbers looks better. And if I zoom it, it will be like this. But then like this, we cannot know what this percentage represents. So let's add a legend to our pie chart and a title. Let's start by adding a title. the title here. Then this is a number of devs in, for example, 2019. Of course, should be in yips 2019, and then thereafter we can add the region to our pie chart. We can add a region to our pie chart. Yeah. We can add a region to our pie chart. The region needs we have to put our region that, for example, the top right of our graphs, top right, and then what do we need to have in our region? We need to have classes, classes, and which with same color of what we have in there. The color is rainbow length of classes. Yeah. So then what do we have? Yes, and then we get this kind of pie chart, but you can see that this region is overlapping our pie chart. We can reduce the size of this region by adding this 6, and we can reduce the size, for example, to be 0.5, and it will change into a new pie chart which looks like this. See, this is better now, and we have this kind of pie chart which looks good. We know which color represent the pedestrians, which color represent the cyclists, and so on. And then we know we have the percentages, and if you add this percentage, they should add it to 100. Yeah, if you add these values, they should sum to 100. Yeah, so now we get our pie chart, and I hope that you have enjoyed this today's presentation. So I hope to see you next time. Please write in the comment and let me know what you want me to talk about next time or in the future. I am collecting data from you guys to know what you really need from me. Thank you very much. Thank you for watching, and see you next time. Bye.